which
Okay.
means they're going to be too much.
So the y-intercept for this first question would be 2.0.
Yep, that's what I think.
The fall. So I'm just going to, yeah.
Okay, what is this slope? So slope is 1.5, right?
Yep.
Yeah, it probably will, but.
Okay.
Yeah, but Lydia has to come back here to take like a biology class. Yeah, they can't do online, and like I would have to do like some other thing here. So we both.
Oh gosh, did you get 12?
It's just a matter of.
I'm still working on it. Sorry, hold on.
Because I did my grad plan and projected to graduate in April 2018.
Oh my god.
So.
Oh no, 7. Oh my gosh, I keep getting different answers. Okay, what's wrong with me?
I got 1. All right, let me do it again because I got 1.
You all got 1?
So right now she's working at a healthcare place.
Okay, so I got 7.
Service for a diaper department.
I still get 1. Okay, let's walk through it then.
Benefits and stuff like that. And so she's just working on the.
Okay, well if you do 16 times 0.25, you get 4.
4, yeah.
And 4 plus 3 is 7.
No, it's a -3.
It's 1.
Yeah.
Oh, it's a -3? Oh
Yeah.
my gosh, I didn't even see that.
20 to 25 minutes. So 20. Put it in for 23.
Oh my gosh.
Good option to think about law
Do you need to bake
school.
something, Em? Are you gonna bake?
It's just something to think about, just keep
I know.
options open.
23.
Yeah, okay, I got 1 as well. Sorry, I didn't even see that.
Oh, that's okay. I just thought, we better walk through it because that's not what I was getting. So, and you know
Okay,
me,
so-
misinterpreting numbers.
I'm gonna turn my screen brightness up so I can see that better. Okay.
It would be interesting to see like
Okay.
what's
Make a
available,
scatter plot of them.
No, that's good today.
I'm just always trying to keep my options open, but if I do like business management with an emphasis, which I just declared this semester, that's finance, I can be specialized in something. I'm just like a broad spectrum.
Yeah.
So we'll see how it goes.
Yeah. I just like I'm sure that never gonna
Maury, my stuff is really slow pulling it up.
Yeah, mine isn't even doing it yet, so
Yeah, mine's struggling.
Do you want to work full time or like trying to be a stay-at-home mom?
So like with what I'm going into, I'm going to until like
Autumn, could you get her 1, please?
long, easier hours, and so like you work in like a dermatologist office and get like good money. So it's just like a matter of like if I really like you can be a surgeon, you can be making like
Yeah.
so I'm like not too worried about like the money. But I know that like until he's done with med school, there's probably.
Oh yeah.
But yeah, I don't know. I think I'd rather just like be a stay-at-home mom than just working all the time.
Okay.
The options not there.
What are we supposed to be doing?
I know we'll probably be having like,
and it doesn't really matter which one we use. We move to the y-axis or the
about me and if you really want to work
x-axis, right?
I don't think so.
But
What's the 3 data sheets?
then I like to support us to
No.
working at the same time. But then, so like once I get like an actual job,
Okay, so I get like a hot dog shape.
Okay, hold on. I'm still. Let's see.
It's like crazy to think about that stuff.
I mean, I think it's a hot dog shape.
Like,
Could be something else. I don't know.
Hey, what did you get? You got what, Susan, Abigail? What did you guys get?
Hot
I
dog.
got a hot dog.
Yeah, I guess
Wait,
that's.
and-
I'm not very good at. I mean, it's just a bunch of. It's wide. It's fat. It's like a hot dog. I guess.
Yeah.
Yep. Okay, that's what I would say.
So this girl in my American Foundations class.
Well, it's not a hamburger and it's not a banana, so yeah,
Right.
I'd say hot dog.
Interview somebody new.
Okay.
Just so I get to know them. So I was talking to this girl, I'm like, oh, are you engaged? Like, I saw her ring. She's like, no, I'm married. I was like, oh, cool. Like, what semester is this for you? She's like, this is my first. I was like, oh, well, how old are you? She's like, I'm 18.
I don't even remember learning any of this.
Yeah, it's appropriate
she's
because
like, yeah, like, over the
it's
summer,
still
like,
within that realm.
got
Hey,
it.
Abigail, can you just turn your speaker down a little bit?
Married, like, in September or
I can
August.
try.
Yeah, I'll be like,
So I'll just mute my microphone.
Yeah, there you go.
That's
Oh,
better.
much better.
Thank you.
I must be a little OCD. Not must be, I must be.
Okay, so if aren't we learning the linear regression? So it would. I mean, we would always use it before on anything else, so it should be able to be used, right?
So you can, I believe what I remember is you just can't use a simple linear regression if it is a hamburger or banana.
Right.
So this is kind of, if like this strength would be moderate.
Right. Yes.
Moderate
But
to
it
weak.
says, it said if simple linear regression is used for these data, the results will not be reliable. Oh, the other one is the simple linear. I read that last one wrong. Okay, so it's the last one, don't you think?
Yeah,
That's
yeah.
what I picked.
Simple linear regression is appropriate for this data.
Yeah.
Yeah.
Okay, I read it as inappropriate. So, okay, perfect.
Okay, so how many observations are in the math?
$139?
Okay, where are you getting that number?
So I'm just going to a math self-efficacy thing, and I'm just going all the way down the chart. There's 139. Is that not? Would that not be considered the observations?
Yeah, I would think so, but then when you look at, okay, so there's 139 there, but when you look at the data, oh, where'd that go? Oh my gosh, I've got all my M&M stuff pulled up.
I know, me
here.
too.
Oh, I can't find it now. It said N was 24.
No, that's got to be your M&Ms because my N says 139.
Oh my gosh. Okay, did I do the right graph? Oh my gosh. I could have pulled up.
All right, I got to close all my M&Ms ones out of here. Okay.
So when you
Okay.
did your graph, did you use score and confidence rating mean?
I did score and confidence rating, yes. Score is on the up Y. Confidence rating was on the X. I don't know, does that make any difference?
No, it shouldn't. You know what? It's lumping all of my data into my M&M stuff.
Oh,
'Cause
no.
that's the graph I got. Okay, so I gotta close this all out.
Yeah,
Oh my
close that
How
out.
did that happen? I'm glad you saw it.
Yeah.
All right, give me a second here.
Yeah, you're fine.
I just feel like I'm losing it. I don't know if my brain can hold much more information.
Me too. This has been like, and then with this stupid project on top of it, I am just, oh my goodness.
Yeah. Okay, I'm going to run if you'll give me a second, I just want to run my Scatterdoc thing one more time.
How many classes are you ladies taking?
I'm doing, well, I was doing 3, but one of mine was just a 1 credit, so it's done. So now I just have 2. I've just got 6 credits right now.
And I have 9 credits.
How about you, Susan?
12, and I'm losing it.
My gosh, ugh.
Yep. Exactly.
Yeah. It's like fundraising. Like they give you like this thing like
Really?
and you literally
On top of a job.
if you want.
Yeah, I don't know
how you do it.
Like when she's not looking.
I have no idea how you do that.
That's what Brett was saying. He would like put something
I don't have family at home anymore.
Is there like one scanner, or like do you both have one? And
Oh, you guys, I'm so sorry. I'm slowing everybody down today.
You're fine, Lori. Don't worry.
or you can go online and add whatever you want to. Like I have some weird
Okay.
things where I'm like, where did you
So now I just have a graph. Did you run any tests on it, Stephanie?
I ran the correlations test, so I did the analyze, correlate, bivariate, and I got the descriptive statistics and the correlations.
I don't know. Cause like most are expensive and
Okay,
Yeah.
but that's
a lot of
the correlation coefficient, right?
he gets like super bad migraines.
Well, the N, it says on the correlations that the N is 139. So doesn't N mean the sample size?
Yeah,
Right, but shouldn't we run
yeah.
estimated regression coefficient?
Like,
Well, we can run that too.
I mean, yeah, I guess.
Like a voice memo or like a
Okay. Hey, Abigail, you've got. Can you please mute your mic again?
Yeah.
and so yeah.
Okay. Okay, I'm
Okay.
almost caught up to you guys.
You're fine.
Okay, so yeah, and sample size is the same as observations? Why are they saying observations?
I don't know.
I don't even remember that.
I would assume that sample size is the same as observations because that's how many we would be looking at, right?
Uh-huh.
Right. Okay. All right.
I mean, that's, for me, that's what I think, but I don't know. I don't know it.
Okay, so on the next question, the explanatory variable is x. I always have to write this down because I forget.
Yeah, I know, me too.
So x is confidence, right? Which would make
Okay,
y
hold on.
4.
Okay, what were you asking, Lori? Sorry.
No, okay, so now they're calling x and y response and explanatory, and x is explanatory and y is response, right?
Yes, let me.
So now we're going to run the estimated regression thing.
Yeah. Okay, but what number are you on?
I am on 9.
Okay. So we're looking at the y-intercept.
So the y-intercept is the score. And then the y-intercept is also the dependent one.
Yes, y is dependent.
Dependent and the response variable.
Yes. All right. Okay. So, what are we saying is the what are we asking? Let me get out of here and see what we're asking.
What is the y-intercept? So what we're finding is the B0 and the B1.
Right.
So we are looking
Does it
at.
tell us what we're looking for? What is it that we're looking for? You know how it said how we're supposed to find out what is dependent upon the other? One of them.
Okay. Well, now so now we're going to that equation. What's that equation? Y hat.
Oh, yeah.
We're going to y hat equals B0, which is the y-intercept, plus B1 times x.
Right.
So we go in and get the information by doing the analyze regression linear dependent.
Right. But what I'm trying to say, I'm trying to figure out which one is the dependent one. Is the score or the confidence rating the dependent?
Okay, the constant is y. So the constant one is.
Wouldn't the constant be x?
Gosh, I put in my notes here that B1 is the. Okay.
If your response is y, wouldn't your x be constant?
No, because x is what changes. I put, okay, this is what I put. First row, and I put y, or BO, is the constant. But I could be wrong, you guys.
Well, I always just look at it as to see what we are looking for. Which one is dependent? Like with the alligator or the crocodiles, the head length was what would determine the body length. So the head length was the dependent. So what are we looking for in this is what I'm saying. Confidence rating.
We are looking for a score because the score is y, right?
Okay, hold on.
Yeah, I gotta go back to my notes.
Yeah, me too.
In fact, I'm gonna go. I'm going to go back into my body.
Wait. Okay. Use the math self-efficacy data to answer these questions. Be sure to use the confidence data for the explanatory variable and the score data as the response variable.
That's y.
Okay. Response variable is y. Okay. Response variable is y.
Isn't that right?
Yes, that's right. Okay. So I'm sorry, I just have to think this through in my head.
No, you're right. I'm just making sure we're right to this point.
Okay, sorry. Okay.
Height is x. Okay, so what I did is I went back to our homework assignment.
Uh-huh.
And I went and put in, I brought up body measurements, corrected again.
Uh-huh.
And we have in there our X is our height and our Y is our weight. And then I'm looking at the answers, and Y is the constant.
Okay.
Let me just double check that on the answer key, but I'm normally...
Why would height be constant? Because it doesn't change.
Well, sometimes sometimes I have to look at definitions and go, well, constant there doesn't mean what constant thinks in my mind.
Okay.
Okay, so if you go back to that body measurement corrected, the Y answer is the constant under column B.
Okay, so I ran my numbers, and I got 18.690 B naught plus 12.695 times X. Is that what you got?
Yeah, I'm trying to get back there.
Okay.
For some reason, on my outputs, I'm losing my outputs when I do stuff.
Uh-oh.
I'm guessing it's pretty much user error.
Just like mine.
Oh no, I lost my, what did I do with my card? There it is. Okay, so this is what I said
Okay.
on my notes. So I have the same thing. I have 18.690 for number 9, and I have 12.695
Yeah.
for number 10. This
That's
is
what I got.
I put on my notes to run this. So I put coefficients are in the understandardized coefficients under B.
Yes.
The first row, Y or BO, is constant. The second row, B1, is the slope.
Yeah.
So, and see, and now, Susan, now you're going to change X. That's why Y is your constant, because you're not going to change that. You're not changing your Y-intercept. You're changing X.
Mm-hmm.
Does that make any sense? Am I looking at that right?
Sounds okay to me.
None of these are negative, right?
None of these are negative.
Okay, so I got 69.47.
That's what I got.
Oh, hallelujah. That is if 9 and 10 is correct, right?
Right. Yes. That's the key there, Lori.
Oh my gosh. Okay, so do we see, and we don't see anything that says observations on here at all?
Mm-mm.
I'm way overthinking that observation thing.
I'll go back through my notes really quick on that one. Let's see.
Well, let's keep going and then we'll go back.
Okay.
Okay, so the confidence data resulted from students evaluating.
Oh my word.
Okay, absolutely no clue what that means.
Yeah, me either.
Is it one of those things that's called something else in the test box?
Okay, so look down at 13 and 14. I'm waiting for my doctor to call. Can you just give me a second?
Sure, that's
Yeah,
fine.
you're fine.
Hello? Okay, that wasn't it. Okay. So I have no clue about the next three questions. None
Yeah,
of
I
them.
know. Oh my goodness. Okay.
But isn't
All right.
that what you were explaining to me about the X and the Y? And then if you change them, you'd have one coefficient and then you would change the Y things. Or the X ones. I wrote. Wouldn't 13 be 1 and then 14 be 2? Or no? Yeah.
I have no idea.
I don't either. How many explanatory independent, that's X, variables are present in the simple linear regression? Well, B1 is considered
You're dependent. You're dependent.
It's the slope, right? So B0 is the y-intercept.
Mm-hmm.
Isn't the slope also called, okay, so then the slope is B1, and so X, there's just one X, and that's X, right?
I think so, but how many explanatory independent, X's independent variables are present in simple linear regression?
Okay, so a linear equation is y hat equals B0 plus B1 times X, right?
Yeah.
So then if you say what everything is, you have, okay, so you have B1 is the, I wrote these in my notes. B1 is the y-intercept, or I mean, excuse me, B0 is the y-intercept.
Yes.
The y hat is the predicted value.
B1 is the slope.
Y. Yeah, B1 is the slope. And X is your...
X is your value, so...
It's, yeah, and it's a variable that can change. And then your y hat is your predicted value for y.
Mm-hmm.
Predicted value for y. So, honestly, I would just say there's one of each.
Yeah.
But I am totally guessing.
Okay, well, I think there's one on the 13 for sure.
That
Let
sounds
me
right
think
to me,
about
one for each.
14 for a second.
Yeah.
The only way for number 14 I would say true is because you have your y hat and you have your y-intercept.
Yeah, I think it's just...
I'm sorry, Abigail, I can't hear Lori. I'm so sorry.
Sorry.
Can you mute? Okay, say that again, Lori.
So when it asks for response or dependent, that's your y, correct?
Yes.
Your
Yes.
y-intercept. So the only reason, so if you look at your equation, you have y hat equals y-intercept plus slope times your x variable.
Mm-hmm.
So you have a y hat and a y-intercept, but your y hat isn't called your response dependent variable. It's called your y hat. So I would just say there's one.
Okay.
The confidence data resulted from students evaluating their confidence for each question.
Yeah, I don't have anything else to say to that, so I guess that makes sense.
Yeah, but I'm totally, I'm totally guessing.
Well, any of us are totally guessing, I think. I don't even remember discussing this. I don't remember reading it.
I don't either, and I'm not finding it in my notes anywhere. I mean, except for when I wrote out what everything. The linear equation is the best estimate, but is not. Each 1 unit increase corresponds. Simple linear, a method used to fit a line to data, to model private data. Regression also allows us to write a linear equation that models the relationship between the independent variable x or explanatory variable and the dependent variable y, or the response variable, which we can use to predict value of y for any given x variable.
Yeah, I have that same note down.
Yeah, so it's got, so I'm going to put 1 for each. If you feel it's something different.
Yeah, I don't have anything else to add. I don't know what it is. I don't know what it is the thing.
Okay, so now let's go back to 12. What? The confidence data resulted from students evaluating their confidence. What is the maximum, that's the biggest, predicted value of y for these values of x? Your answer should be exact.
Really?
Abigail, you got to turn that off. Because there is a positive correlation, we can use the largest x value. Okay, so our x value, where do you get an x value from?
Well, so we have to go back to the first chart, and our x data is the confidence data. So our x value, we have to go back through, I'm guessing we have to go back through and find the highest, but there's 139 of these.
Okay, confidence, the confidence is x, right?
Yes, the confidence is x.
Okay, all right. So what we do is we find the highest confidence rating.
Yep.
I have a 6.0.
I've got a 6.0 too. Well, 6.0 also.
Yeah. Okay, that's the highest one that I see. It's number 107.
Yep, that's the one I've got. And I started from the bottom. Did you start from the bottom or did you start from the top?
I started from the top, but I'm going back up. Okay, so that's so we can use to find the largest predicted value of y. So then let's have x be 6, and we'll just do that linear equation again.
Yeah.
Right?
Okay, hold on. Wait, let's think. Okay, say that again. X be 6.
So if x is 6.0, then we have y hat equals.
Okay, yeah, right.
18.690 plus 12.695 times 6.
Okay.
But that doesn't. Yeah, that's the value of y. So I get 94.86 with that.
Okay, I'm almost there. Yep, that's what I got, 94.86.
Hint, because there is a positive correlation, we can use the largest x value to find the largest predicted value of y. Your answer should be exact. What does exact mean?
I don't know.
94.86 or 95?
I don't know. I'm gonna leave it at the decimal because that's what exact would be. We wouldn't be rounding it, right?
That's what I would think. And it stayed as decimals all the way through our homework and preparation assignment. They never rounded. Just kind of looking through all of this. Okay, so I got 94.86. Is that what, Susan, Abigail, is that what you guys got?
Yeah.
Okay, you want to go back through the answers?
Yeah, we probably better. All right, I'm going to look up that one about sample size and observations or whatever. Let's see if we can find that.
They have to be the same.
I mean, that's the only thing I can come up with.
So it says the sample size of a statistical sample is the number of observations.
Oh,
Yeah, okay, good.
And I just Googled that.
Okay.
Okay, good.
Get myself on.
Okay, love you.
Love you. Bye-bye.
Okay, so let's go back over these. Is everybody ready? Tell me when you guys are ready and we'll go back over them.
I'm ready.
I'm ready.
Okay, so 3 is 2.0. 4 is 1.5.
Yes.
5 is 1.0. 6 is hot dog. 7 is the last one. Simple linear regression is appropriate for these data. 8 is 139. 9 is 18.690. 10 is 12.695. 11 is 69.47. 12 is 94.86. 13 is 1 and 14 is 1. My gosh, I just have no, I'm just guessing.
Yeah, I know.
I looked up on, well, the website. It says, with regards to linear regression, the number of explanatory variables dictate the type of regression analysis used on the data. If there's only one explanatory variable, simple linear regression is used. If more than one explanatory variable is present, multiple linear regression is used. Does that help any?
You know what? I remember reading that under the section of linear equations. Because here we've never done linear equations, and then all of a sudden we're doing this stuff where we have to know linear equations.
Yeah.
Yeah,
And
it's
so you
in the
can
linear
do-
regression equation.
Right, but since
In
this
the
is
linear
a simple linear regression, I think that makes it just one.
I think so too.
Yeah, that's what it sounds like.
Susan, where did you find that info?
Linearregression.org. Put it into a search. How's that?
Okay. I'm going to quickly just go back to our homework. And look up simple linear regression under that section that had that.
Oh, that's a good idea.
Click here for a review of linear equations. Slope of a line is a measure of how steep it is. Oh my gosh, it just hurts my head to think about.
I know. I know.
I don't know what else it would be, you guys.
I can't imagine that it would be more than. I can't imagine that it would be more. I don't even remember learning that or reading anything about it if it is. So.
I remember reading somewhere that you can have all these different, like B's. Like you can have B0 plus B1 plus B2 plus B3 plus B4 plus B5.
You
But
remember reading that?
If you have that, you need to go to a statistician to figure out how to do that because we're not dealing with that.
Yes, I remember reading that now.
Okay.
Yes, I remember that.
I think you fit that description now.
Yeah.
So, if it's a simple linear regression,
Yes.
I don't know, you guys. I have no idea. Should we just
Okay,
submit and be done with this?
I know.
I hate to score poorly on this because I want my grade to be solid before I go into the
Okay,
final
here it is.
exam.
I found it. I want my grade to be solid too. I know. Okay, it says sometimes it is necessary to use more than one predictor, independent variable, to predict the value of a response, a dependent variable. For example, if we want to predict the stopping distance for a car on dry roads, we might want to use the A, the initial speed of the car, B, the weight of the car, 3, the amount of the tread on the tires,
Yeah.
blah, blah, blah. Although it is fairly straightforward to create a model and get the estimated multiple regression, so there it says multiple regression
Yep.
equation, the interpretation of the results can be a little tricky. If you need to conduct multiple regression, multiple again, that is regression with several predictor variables, you may want to study the topic in depth or hire a statistician.
Okay.
Woo-hoo, I think we're right. So,
I knew.
but that is not a guarantee that we are
I
right.
remembered reading that somewhere. Okay, and are we okay with all the other data here?
I think so. That's the only way I know how to do it, so I think it's...
We got a 100.
Oh, you already submitted it. Oh, good.
I did. Sometimes I just have to go for it.
Yay!
That is
Oh,
okay, but
this class cannot be done soon enough.
So what did you say for 13 and 14?
Oh.
Sorry.
1 and 1?
Yes.
I threw a girlfriend card and I'm like, whatever. Because he's done stupid things like that all the time. But he's back and he said all that.
Well,
Yeah, 13 is 1 and 14 is 1.
Right.
Don't
This is my food. Exactly. Thank you. Someone will understand.
Okay,
what, you telling me about what happened last night?
so
Yeah.
now, Abigail, you got to turn that.
I'm sorry.
Okay, so now we've got to go to our project.
Yes.
Oh my gosh, that just caused me a lot of stress.
I bet, Lori. Oh my goodness, you have been working really hard on that.
No, I mean this group quiz just caused me a lot of stress.
Oh.
Okay. But that's why this group helps me is because we have to discover stuff on our own
Yeah.
and discuss it, and that's what really helps me to learn. So now when we get that question again,
You'll be
we're
prepared.
gonna all know, yeah.
Mm-hmm.
And I'm gonna write those stupid questions in my notes.
Me too. Mm-hmm.
Okay. So back to this thing.
Okay, I gotta go.
Okay, that's fine.
But yeah, just if you need anything, just shoot me an email and I'll respond and get you whatever you need.
Okay.
Okay.
All right.
Thanks, Abigail.
Abigail.
No problem.